Hi everybody, today I'll show you how to do problem number 3 from chapter 7. So, problem 3 states, Batman, whose mass is 80 kilograms, is dangling on the free end of a 12-meter rope, the other end of which is fixed to a tree limb above. By repeatedly bending at the waist, he is able to get the rope in motion, eventually making it swing enough that he can reach a ledge when the rope makes a 60-degree angle with the vertical. How much work does the gravitational force on Batman? How much work was done by the gravitational force on Batman in this maneuver? So, here I have drawn my diagram. Batman is swinging on this rope. Here's the center of the circle. He's going in like a circular motion. And we are given that his mass is 80 kilograms. The length of the rope, which I called R because it's the radius of the circle, is 12 meters. And I'm saying his displacement from here to the ledge is delta x. And we know that to go from here to the ledge, he has to travel 60 degrees. So first we know that we can solve for work by using this equation. Work is equal to F times X cosine theta. And since this question asks for finding the gravitational force in relation to work, we know that's just another way of saying F is equal to weight, since weight is the gravitational force in this case. To find X, or the displacement, we can look at this diagram that I've drawn. We can see that since these two sides of the triangle are the same length, this must be an isosceles triangle. Where this is 60 degrees. So that means that these two angles must be the same. So for this to be a triangle, this must be 60 degrees, and this is 60 degrees, which I'll label in this right now. So this is, now we can actually see this is an equilateral triangle too. So this is length R, that's length R, so that means it's the change in X, its displacement is also R. So we can put into this equation here, X is equal to R, and then cosine theta. To find theta, theta in this formula means the angle of the force in relation to the direction of its displacement. So here, what we're trying to find is the force is its weight, or Batman's weight, and the displacement is going this way. So what we're trying to find is this angle right there. So what we can do is, if you look at this, these are two parallel lines, these two verticals I've drawn in right here, and this, the displacement, is a transversal. So what we can do is say, we can use some geometry skills, and using alternate interior angles, we can say that theta is equal to 60 degrees. Right here. So that is 60. But we know that this force is going downwards, whereas this this displacement is going upwards. So you know that's actually negative 60 degrees in relation to the displacement. And to make it more clear to visualize, we can kind of rotate this diagram so that X, or the displacement, is horizontal. I've drawn it again down here just so it's easier to say. Let's say this squares Batman. His displacement is going horizontally, and the applied force, or the weight, is going this way. So thus we can see that theta would be negative. So now going back to our equation, we know, so we found that theta is negative 60 degrees. We have our mass, we know what G is, and we know what R is, and we can just start plugging those numbers in now. M is 80 kilograms. G is the acceleration due to gravity. R is the length of the rope, which is 12 meters. And cosine theta is negative 60 degrees. Put that all into your calculator and you get negative 4,704 joules, which is equal to negative 4.704 kilojoules. And that would be your answer.